Hi everyone, welcome back to EduVibe, where learning comes alive for all high school students. Today's our topic is another topic of 1D kinematics, which is the kinematic equations. So today we have main focus on the kinematic equations, which is the most easy topic of this unit, because all the equations which we use there, they is on your data sheet. So there's no need to memorize like these all six equations which are mainly used in this topic. So kinematic equation in general, if an object has a constant acceleration, you can use the following equations. So first equation you will all familiar with, that acceleration equation. This equation is like final velocity minus initial velocity upon time taken. So it's the simple which we already done in previous video. Next one is like delta d, which is the displacement, which is like initial velocity addition with final velocity times t upon 2. Next one is the average velocity, which we again familiar with, which is initial minus final velocity, initial plus final velocity, and it's divided by 2. Again, if you have like initial velocity, you have acceleration, so you can, and you have also time, so you can find the delta d with this equation, which is final velocity times time plus half acceleration times scale. And if you have final velocity, initial velocity, and you can take their stair for both, and you can get the you can get the acceleration from there, and you get the displacement too. So you can use this formula to for calculating anything which you want. And the last formula, which is like similar with this, which we discussed, this one and this one is like similar formula. The difference is that there we use the initial velocity, here we use the final velocity, and the rest of the formula is same, and we also that there is a plus, we do minus in this. So this is the same formula, and these are like six formulas. This is equations, kinematic equations, which we discuss, which we use in the examples which we discussed today. One more thing before starting with the example, that the object, if the object which is the maximum displacement, if the question says that the object height reaches the maximum displacement, so automatically the object comes to rest. Then value object comes to rest, and if they're starting, if they on the starting they goes to like maximum displacement, so their initial velocity goes to zero. So the initial velocity goes to 0 meter per second. If the ending, they at the end they reach the maximum displacement, so their final velocity should be 0. So that's how the velocity works. And the last, that the object, if the object has a constant velocity, the acceleration is 0. If they mention that the velocity is constant, and they somewhere they said that velocity is constant, so the acceleration is 0, and you can use directly this formula. If the acceleration is 0, so you no need to write like use this formula or this one or like this one. So you can directly use that formula, which is delta d upon t, which is equal to the velocity. So here's the examples. So we discuss the examples to get more use with these equations. So an Indy 500 race car's velocity increases from 4 meter per second to 36 meter per second over a time interval of lasting 4.00 seconds. So how far does the car travel during the time interval? So how far they go? So you have to find the distance for this. So for these questions, like there are so many variables, so many things we have given in this question. So firstly, I suggest that firstly write the list of the things which you have given and which you have to find. So here they said that they starting with they increase the velocity from 4.0 to 36.0. So they start with the 4.0, which is our initial velocity. So right over there, 4.00 meter per second is our initial velocity, and they goes to 36.0 meter per second, which is our final velocity. And they also give us the time interval, which is 4.0 seconds. So our t is 4.0 seconds, and how far does the travel during the time interval? So we have to find the distance. So from these sets, which formula which is best suited with this example? So you have like initial velocity to you have a final velocity, and you also have time, and you have to find the distance. So you can use this second equation to calculate the distance. So here you write that equation first, which is again is on your data sheet. So this is the equation. You have to find delta D, put that vector, small vector on this, because distance or distance are the same. These are the vector quantities. You have the initial velocity, which is 4.00, plus final is 36.0, divide by 2, and times t, which is 4.00 seconds. So to find this, you can solve this. 4.0 plus h is 40, like this is 40.0.2, and times it by 4.0. You can cut this on 2 and 1, so you get 80 meters. So it's a 3 seconds, so you can write 80.0 meters. So it goes like, did not mention that which direction they follow, so you can no need to write any direction in this. So this is your distance, which is 80.0 meters. So that's how far the car traveled during this time interval. So this is like a more like a easy example, like a easy equation we use. So let's go to the more complex one. So here they write that while gliding down a steep hill, the bike rider experiences a constant acceleration. They mention that there is a constant acceleration of a time interval of 4.50 seconds. They've given us the time, so write that time over there, which is 4.50 seconds. Read the problem and write what you have. Then we have at the end of the interval. So there is an end of the interval now, and it reaches a final velocity of 7.50 meter per second. They doesn't like give you that the what is the initial velocity. They didn't tell you about that, how that the object or that bike rider comes from the rest. They didn't write anything, so exactly they write that the initial velocity is 7.50. So write that final velocity over there, which is 7.50 meter per second, and has traveled 19.0 meter. So they travel all that distance, so it is a distance. So that our 9.0 meter is the distance. So we have to find what is the acceleration of the bike rider down the hill, and rider down the hill. So they goes down the hill, and what's the acceleration for this? So you have to find the acceleration vector, which is that. So what's formula you have to use? You have time, you have final velocity, you have distance, you have to find acceleration. So from these ones, so which is the best formula you use? So you have to use this formula, but you don't have the initial velocity. But we have that formula which is correspond to same like this formula. So you can use this. They mentioned that there is a final velocity, we have time, we have distance, we have to find acceleration. So we isolate the acceleration and find that for this particular question. So put that equation on this, like delta D is equal to final velocity times t minus half a t squared. So you have distance of 9.0 meters, which is equal to the final velocity, which is 7.50 meters per second. You have time of 4.50 seconds minus half. You have acceleration, you have to find this. You have time again, which is 4.50 seconds, but it will be now square of this. So that's all. So now you have 19.0 meters, but if you see here this one, if you solve this, so what you get about 33.75 meters, because second cancel from here, and from here when you solve that half and multiply by 4.50, you get something about 10.125, and the acceleration goes multiply with this, and if you need you put the bracket for this. So our main focus is to find that acceleration. So let's isolate this. So how can you isolate this? The 9.0 meters is goes over there is positive, so goes over there is negative. Now 33.75 meters, and you get minus this of this. So you get from here, which is you can suppression of this, you get minus 14.75. This is the multiplication over there. When it goes down, it goes divide. So you have to divide this, like minus 10.125 is equal to acceleration vector. So your now acceleration should be separated out, and now you can cut it out and divide this. So when you divide, you get acceleration vector is equal to 0.1458, which is meter per second square. If you want that set answer, so acceleration is like about shifted that point, like this point shifted over there, so it's 1.4, you need 3 seconds, so 1.46. You can write if you want is to 10 raised to 1, but it doesn't matter because it's the same thing. So your answer for acceleration is 1.46 meter per second squared. So what is the acceleration of the bike rider? So it's 1.46 meter per second squared. That. So that's how you can deal with the more like a complex type of stuff. But this is the easy way to do this. So next, and this is the last example for this. So you can go for it. So the car starting at the rest. Now they mention a car starting at the rest. They start when they sit on the rest. So that's mean that our initial velocity is 0 meter per second now. So they mention that. And then it accelerates forward at an average rate of 5.8 meter per second square. So you can see from there the units are like meter per second square. So from here you can identify that this is acceleration. So now our acceleration is given, which is 5.8 meter per second square. Then how much time would it take for the car to travel a displacement of 70 meters? So they given us D, which is 70 meters, and they want how much time. So we have to find the time for this now. So the same things we have given like in previous question, like in this question, but this time we have that initial velocity and here we have the final velocity given. So the question is same, we have to find the time. We have now D and A2, so you can use this formula where they mention V, I, T, A and D. So from here you get the T. So how can I get T? Let's go for it. So our equation is delta D, which is equal to VIT plus half AT square. So from here you know that what is D, but here's the thing, Vi is equal to 0 meter per second square. If that Vi is equal to 0, so 0 into T is becomes 0. So from here your VIT goes 0 and you only left with delta D, which is half a T square. So let's isolate the T. So with where dt goes there and is 2 rows over here, you get 2 delta t, and this goes down, you get a. And now this whole value goes for like square. When we that the square towards there, so just put square on that like. So now you have to put like all the values on that and find the t. So t is equal to 2, delta d is 70 meters, and our acceleration is 5.8 meter per second square. So like it's whole of the square, you get 17 to 2 and divide by 5.8 and you get 4.19 whole square, and you get about 4.9 seconds. So it two said this. So you get about time of 4.9 second, which is a car to travel distance of 70 meters. And this how the question works. There's a lots of way to like manipulate the questions and get the use of the formulas, and sometimes we use the two formulas like we do in our when we do the extra questions for this unit. We will cover those questions too. So here's the for this video. This is a kinematic equation, which are like a which are the easy topic. You just know that formulas which are on the data sheet, and you want that how you can get to the answer. So let's so learning made simple with EduVibe. Learn smarter but not the harder. Please like, share, and subscribe to my channel. If you have any questions about this topic, let me know in the comment section. We only left with one topic of this unit, which is like the projectile motion. We will cover this topic in the next video. So see you in the next lesson. Till then, stay connected with EduVibe.